Welcome. Today we're talking about how to find acute angles inside a right triangle using inverse trigonometry. Now it might be helpful first to figure out what an inverse function actually is. Now this is a function that basically undoes the original function, getting you back to whatever you started with, usually a variable. So for example, a simple example you've been using for a long time, subtraction is the inverse of addition. So if you have an equation that involves addition and you go to try to solve it, you use subtraction. But if you focus just on the left side, just what's happening to x, you see we had an x that was adding 3, so we subtract 3, which gets us right back to x, just plain old x at the very end. Now another example, division is the inverse of multiplication. So if you have an equation that uses 3 times x equals 12, you would divide by 3 to solve that. And again, focus on that left-hand side. We had an x times 3, but then divide by 3, and by the time we get to that last line, we have just plain old x. So it's a way to isolate your variable. Square root is the inverse of squared, or that quadratic function, that raised to the second power. So if you have x squared equals 64, you would take the square root, which would get you back down to just plain old x. Our new one for today is that inverse sine is the inverse of the sine function. I know it's a quite creative name. Sometimes it's also called arc sine, but not always. So we just generally keep it inverse sine to remind you that it is the inverse of the sine function. So when we have an equation that we put together and it starts to look like this, where we have sine of some mystery angle, which we're using theta here, equals our ratio. So remember, the sine of an angle equals the opposite side over the hypotenuse. We can actually solve this. We can get that variable, that theta, that angle that we're looking for, all by itself by using the inverse sine. Now this is going to look a little complicated here for a second, but just stay with me. So what we're doing, what this step is showing, is basically taking the sine, the inverse sine of both sides, which is kind of a strange thing to have happen, but on that left side, since it's the inverse sine of the sine, it gets us right back to theta. It gets theta all by itself, equaling something that we can put into our calculator. So we can solve this just by the way it looks here on that last line. In your calculator, you find the inverse sine button. It should be either a secondary function of your original sine function or a button right next to it. And then you, in parentheses, use your 7 divided by 12. You don't even have to find the decimal equivalent first. And then we'll find out that theta there must have equaled 39.5. So as complicated as this seems, it's really just a way to get your theta, your unknown angle, out of the sine function and able to be isolated. What will end up happening as you look at your triangles and you're putting together, how can I solve this? You'll start with a function that looks like this. You'll start with an equation where you've got sine of a mystery angle equaling some ratio. And you'll have to kind of flip it around to use the inverse sine. So why do you need this? Basically to find the acute angles of a right triangle when you're only given side lengths. So probably up until this point, you were always given one angle and at least one side. And then you could find the rest of everything just based on that. But in this case, with this picture, we don't know either of the acute angles. But we're going to find the value of x. So here we go. Our steps are going to be basically the same as they were in our last video when we already knew the angle and we were trying to find the sides. So we'll walk through the steps and I'll show you how they still apply. So step 1, identify the reference angle. In this case, it's just the angle that we're solving for. Sometimes you have the option, if you are solving a triangle completely, you'll need to find both acute angles. You can start with either one. You just decide which one is my reference angle right now. In this case, we're using angle B, which is marked as x degrees. Then step 2, we're going to label the sides. So I know for sure 23 is our opposite side because I have to cross the triangle to get to that one. The 31, we have to pay a little more close attention because both the adjacent side and the hypotenuse make that angle B. So we have to make sure we're picking the right one. Since our 31 there also is part of the right angle, this is our adjacent side. The hypotenuse is always across from the right angle. It's not touching the right angle. So we have adjacent and opposite. Now, step 3, we're still going to have to decide which trig function is applicable. Remember, we have sine, we have cosine, and we have tangent. So tangent is the one that includes opposite and adjacent, so that's what we're going to use. We'll insert our values. So theta is just that general mystery angle. We have x here, and opposite and adjacent, 23 versus 31. Now, to solve this, though, we can't go in our calculator and say tangent of x. It won't do anything for us. So we need to use the inverse tangent so that x is isolated and solvable. Now, that right-hand side, that tangent with the -1 that looks like an exponent, that's inverse tangent of 23 over 31. That's what you put in your calculator. And you should, if all your settings are right, get your answer to be x equaling 36.57 degrees. Now, the rounding that you do just depends on whatever your assignment is and what they're asking you to round to. But that would be our basic answer. So just to summarize, in order to find acute angles using inverse trigonometry for these right triangles, same basic steps as before when we were finding side lengths. You're going to identify the reference angle. That is the one you're trying to solve for. You might be able to do this twice. You get to choose which angle you're solving for. You're going to label the sides. You'll decide which trig function is applicable, insert your values, and solve. But remember, you're solving using the inverse function. So just as our example from the last one, even if you decide that tangent is the trig function that is appropriate, remember we have to switch that to be the inverse so that we can find and solve for that mystery angle. Thank you for joining me, and I'll see you soon.